Step back in time with me, way back, to the land of pharaohs and pyramids. We often marvel at the Great Pyramid of Giza or the temples at Karnak, but have you ever stopped to wonder how they did it? I mean, really think about it. No power tools, no advanced computers, just sheer human ingenuity and a whole lot of grit. This is the story of the very first engineers, the master builders of ancient Egypt, who literally shaped a civilization out of stone and sand. Their story doesn't start with a grand blueprint for a pyramid. It starts much smaller, with the lifeblood of Egypt itself, the Nile River. Every year, like clockwork, the Nile would flood, bringing rich, fertile silt to the farmlands. This was great for crops, but it was also a huge logistical nightmare. The floodwaters would wash away property markers, leading to endless disputes among farmers. Who owned what piece of land? It was chaos. This is where the first Egyptian engineers, or harpodonoptai as they were known, which literally means rope stretchers, came into play. These weren't guys in hard hats with blueprints. They were brilliant surveyors who used simple tools like knotted ropes and sighting poles to re-establish property boundaries after each flood. They developed a practical form of geometry, a way to measure and divide land with incredible accuracy. This wasn't just about settling arguments. It was about creating order, about establishing the very foundation of a stable society. This fundamental skill, the ability to measure and manipulate the physical world, was the first spark of Egyptian engineering genius. From managing the floods, the next logical step was controlling them. Early Egyptians realized that if they could manage the Nile's water, they could expand their farmland and secure their food supply. So, they began to build. They dug simple irrigation canals to divert water to fields further from the riverbank. They built dikes and levees from mud and reeds to protect their villages from the floodwaters. They even created large basins to store water for the dry season. Think about the project management involved. It required organizing huge numbers of people, coordinating their efforts, and planning for the long term. These early hydraulic engineers were learning how to reshape the landscape to serve their community's needs. They were turning a powerful, unpredictable force of nature into a reliable partner. This mastery over water wasn't just practical. It laid the groundwork for the more ambitious projects that were to come. It taught them how to mobilize a workforce and manage resources on a massive scale, skills that would prove essential for their next great challenge. And that challenge was building for eternity. The early Egyptians believed deeply in the afterlife, and they wanted tombs and temples that would last forever. Their first attempts were structures called mastabas. These were flat-roofed, rectangular buildings made of mud brick, built over an underground burial chamber. They were impressive for their time, but mud brick just doesn't stand up to the ages. It erodes, it crumbles. If you wanted to build something eternal, you needed a better material. Enter stone. The Egyptians had access to vast quantities of limestone, sandstone, and granite. But cutting and moving massive blocks of stone with nothing but copper tools and human muscle? That's a whole different level of engineering. They developed copper chisels and saws, which they probably used with sand as an abrasive to slowly grind through the rock. They learned to exploit natural fissures in the stone, driving in wooden wedges, soaking them with water, and letting the expanding wood crack the block free. It was slow, painstaking work, but it was effective. The real game-changer was a man named Imhotep, the brilliant vizier and chief architect to the pharaoh Djoser around 2650 BC. Imhotep had a revolutionary idea. Instead of just one mastaba, why not stack several on top of each other, each one smaller than the one below? The result was the step pyramid at Saqqara, the world's very first large-scale stone building. It's a breathtaking leap in architectural ambition. It wasn't just a tomb. It was a stone mountain, a stairway to the heavens for the pharaoh's soul. Imhotep and his team had to solve countless problems. How do you lift heavy stone blocks higher and higher? They likely used earthen ramps, which they would build up alongside the pyramid as it grew. How do you ensure the structure is stable? They built it with a core of smaller, rougher stones and cased it in finer, well-dressed limestone. The step pyramid wasn't perfect, but it was a crucial proof of concept. It showed that building on a monumental scale with stone was possible. It set the stage for the next, even more audacious, chapter in Egyptian engineering. After the step pyramid, there was a period of intense experimentation. You can see the learning process frozen in stone. At Medum, a pyramid started as a step pyramid and was later converted into a true, smooth-sided pyramid. But its outer casing eventually collapsed, revealing the original structure underneath. A lesson learned. Then came Pharaoh Snefru, the father of Khufu, the builder of the Great Pyramid. Snefru was obsessed with perfecting the pyramid form. His first attempt is now known as the Bent Pyramid at Dosha. They started building it at a steep angle, about 54 degrees. But partway through, they must have realized the structure was unstable. You can imagine the engineers pointing out stress fractures, worried the whole thing might come down. So they made a mid-construction course correction, changing the angle to a much gentler 43 degrees, giving the pyramid its distinctive bent shape. It's a fascinating snapshot of ancient engineers adapting on the fly. Unsatisfied, Snefru tried again, just a short distance away. This time, they got it right. The Red Pyramid, named for the reddish hue of its limestone, was the world's first successful true, smooth-sided pyramid. They used the lessons from the Bent Pyramid, starting with that safer 43-degree angle from the very beginning. It stands today as a silent testament to their perseverance and their ability to learn from their mistakes. Snefru's engineers had finally cracked the code. They had mastered the art of monumental stone construction. All this incredible innovation and hard-won experience culminated in the ultimate expression of Egyptian engineering, the Great Pyramid of Giza, built for Pharaoh Khufu. It is a masterpiece of precision and scale that boggles the mind even today. For nearly 4,000 years, it was the tallest man-made structure on Earth. It's composed of an estimated 2.3 million stone blocks, some weighing as much as 80 tons. The precision is what's truly staggering. The base is almost a perfect square, with the sides aligned almost perfectly to the cardinal points north, south, east, and west. The difference in the length of the sides is just a few centimeters. How did they achieve this with their simple tools? They likely used the sun and stars for alignment, creating a level base by flooding the foundation with water and marking a level line. And how did they lift the stones? The ramp theory is the most widely accepted. Whether it was a single long ramp, a spiral ramp that wrapped around the pyramid, or some combination, we don't know for sure. But what we do know is that it required an incredible feat of project management. Tens of thousands of skilled workers, not slaves, as is often depicted. But paid laborers were housed, fed, and organized into efficient teams. They worked with a shared purpose, a national project to ensure their king's eternal journey, and, by extension, the prosperity of the entire kingdom. The Great Pyramid is more than just a big pile of rocks. It's the culmination of centuries of knowledge, passed down and refined from the rope stretchers of the Nile to the master builders of Giza. It represents the pinnacle of early Egyptian engineering, a civilization that learned to measure their world, control their environment, and then build for eternity. Their legacy isn't just in the monuments they left behind, but in the enduring spirit of human ingenuity they represent. They show us what's possible when we dare to think big and build bigger. How did an ancient civilization, thousands of years ago, build these colossal structures that still defy our imagination today? We often hear about the brilliance of their architects and the sheer manpower involved. But what about the tools? The very hands-on instruments that turned mountains of stone into monuments for eternity. Today, we're going to dig into the toolbox of ancient Egypt and uncover the simple, yet ingenious, tools that built an empire. It's a story of innovation, resourcefulness, and the incredible evolution from simple stone and wood to the dawn of the Bronze Age. Forget the myths about alien technology. The real story is far more impressive. It's a testament to human ingenuity. Let's start at the very beginning. In the early days of the Old Kingdom, imagine you're a worker at a quarry along the Nile. Your job is to extract massive blocks of limestone or granite. What do you have to work with? Your most basic and essential tools are made from the very material you're working on, stone. Hard, dense dough-right pounders were used as heavy-duty hammers. These weren't fancy. They were essentially carefully selected, fist-sized rocks, but they were incredibly effective. Workers would use these stone pounders to relentlessly bash away at the bedrock, slowly but surely creating trenches around the block they wanted to extract. It was brutal, repetitive work, but it was the foundational step for every single stone building in Egypt. Now, just hammering away at rock isn't enough. You need a way to create precise cracks. This is where the brilliant simplicity of wooden wedges comes in. After pounding out a line of small holes or a trench with their stone hammers, workers would insert dry wooden wedges tightly into the gaps. Then, they would pour water over them. As the wood absorbed the water, it would expand with immense force. This slow, powerful expansion was enough to exploit the natural cleavage planes in the stone, causing a massive block to split cleanly from the rock face. It's an amazing example of using natural processes to do the heavy lifting. No dynamite, no complex machinery, just stone, wood, and water. This technique allowed them to quarry the gigantic blocks needed for pyramids and temples. Once the blocks were quarried, they had to be shaped. This is where a new material enters the scene: copper. Ancient Egypt was rich in copper, and their metallurgists became masters of their craft. They created copper chisels and saws. Now, you might be thinking, isn't copper a relatively soft metal? You'd be right. A pure copper chisel would blunt very quickly against hard granite. But the Egyptians had a trick up their sleeve. They learned to work harden the copper by repeatedly hammering it, making the cutting edge much more durable. For sawing through large blocks, they would use long, toothless copper saws. The real cutting power didn't come from the saw itself, but from an abrasive sand slurry. Workers would pour this slurry, likely containing hard quartz particles, into the cut, and the back and forth motion of the saw would grind away the stone. It was a slow, laborious process, but it allowed for incredibly straight cuts. To use these copper chisels effectively, you needed something to strike them with. A stone hammer would shatter the softer copper tool, so they used wooden mallets. These were typically carved from a single piece of hardwood, with a distinctive conical or bell shape. You can see depictions of these mallets in countless tomb paintings and reliefs. They were the perfect companion to the copper chisel, providing enough force to chip away at stone without destroying the precious metal tool. The combination of a soft mallet and a hard chisel was the standard toolkit for sculptors and stonemasons, allowing them to carve intricate hieroglyphs and detailed reliefs that have survived for millennia. Let's not forget the importance of measurement and planning. The precision of Egyptian construction is legendary. The Great Pyramid, for example, is almost perfectly aligned with the cardinal directions. This wasn't guesswork. They used simple but highly effective tools for surveying and leveling. Plumb bobs or weights suspended from a string were used to establish perfect vertical lines. For horizontal leveling, they used a frame levels. This tool looked like a capital A with a plumb bob hanging from the peak. When the bob aligned with a mark in the center of the crossbar, the surface it was resting on was perfectly level. They also used long cubit rods for measurement, standardized units that ensured consistency across massive building projects. These simple tools were the ancient equivalent of our modern lasers and GPS systems, and they were used with astonishing accuracy. As we move from the Old Kingdom into the Middle and New Kingdoms, we see a significant technological leap: the introduction of bronze. Bronze, an alloy of copper and tin, was a game changer. It's much harder and more durable than work-hardened copper. This meant that tools like chisels and saws could hold a sharp edge for much longer, increasing the speed and efficiency of stoneworking. Bronze tools could withstand more punishment, allowing for more detailed and refined carving, especially on harder stones like granite and diorite. This metallurgical advancement didn't just improve old tools, it allowed for the creation of new and more complex designs. The arrival of bronze marks a major step forward in the technological prowess of ancient Egyptian builders. It made the impossible possible. Think about the process of finishing a statue or the face of a temple wall. After the rough shaping was done with chisels and saws, the surface needed to be smoothed. For this, they used rubbing stones and sand. Workers would patiently rub the surface with blocks of sandstone or other abrasive rocks, gradually grinding away any imperfections. Using finer and finer grits of sand, they could achieve a polish that was as smooth as glass. This meticulous finishing work is why so many Egyptian statues and reliefs feel so lifelike and perfect to the touch, even after thousands of years of erosion. It was the final, patient act of craftsmanship that brought the stone to life. Transporting these multi-ton blocks from the quarry to the construction site is another feat of engineering. How did they do it without wheels, which were not used for transport in this context? The evidence points to the use of massive wooden sledges. A block would be loaded onto a sledge, and teams of hundreds, sometimes thousands, of men would haul it across the land. To reduce friction, they had a clever solution. Tomb paintings, like the famous one from the tomb of Imhotep, show a man standing at the front of the sledge, pouring a liquid, likely water, onto the sand in its path. This simple act of wetting the sand would harden it, drastically reducing the friction and making it much easier to pull the immense weight. Combined with rollers and ramps, these sledges were the ancient Egyptian equivalent of a heavy-duty freight truck. As we look back at the incredible array of tools used by the ancient Egyptians, a clear picture emerges. It wasn't about having one single miracle tool. It was about a system, a combination of simple machines, clever techniques, and a deep understanding of natural materials. Stone pounders, wooden wedges, copper saws, bronze chisels, plumb bobs, and sledges. Each tool had its specific purpose. It was the skilled hands and intelligent minds of the engineers, masons, and laborers that brought these tools together to achieve monumental results. Their success lay in their mastery of the basics, their patience, and their relentless drive to build for eternity. The legacy of their tools is written in stone across the entire landscape of Egypt. So, the next time you marvel at an Egyptian obelisk or walk through the halls of a temple, take a moment to think about the humble tools that made it all possible. Think of the rhythmic sound of stone pounders, the groan of a sledge on wet sand, and the sharp tap of a wooden mallet on a bronze chisel. The pyramids weren't built by magic. They were built by masters of their craft, using tools that were as brilliant as they were simple. The story of ancient Egypt is not just a story of pharaohs and gods. It's a story of human innovation, and it all started with a simple toolbox